There were a lot of interesting slides there in terms of data. Now, you were looking at the scores. One of the things I was trying to understand is when you're looking at those different benchmarks, and as you said, it can look a little bit scary if you're down at G. And I do understand that it's been done a bit like the energy efficiency, but what sort of expectations are being placed in terms of what you need to do to be up in that kind of CBA band that you were explaining?
It is a challenging work for us. It's not easy, especially when we work with such tight time frames. Consultancies here from consultancy background understand what I'm talking about. In the region, we work with very, very fast delivery time frames, and it's really challenging to look at this and find time to look at carbon while we have to meet all the deliverable dates. We do rely a lot on parametric modeling and coding. Recently, a lot of our young engineers are helping on that. This is a great tool to expedite these reworks and these reiterations, because we do need a lot of these in order to improve our carbon metrics. Sometimes, we are bound by certain types of materials that are preferred in the region and are competitive in terms of cost and buildability. So with this in mind, we have to do a lot of iterations on changing grids, changing load paths in order to reduce carbon. It is challenging. It requires technology and digital as a really big asset for us to use, but mainly that's how we try to improve. From starting point of 500, 550, even in a simple villa where you would expect things to be easy relatively to a high-rise building, we are at the bottom of the scores when we start. Yeah, when we start, we are really at the bottom. And we see that there are easy wins. An easy 20% can be achieved by looking simply at our margins of utilization. And then we go up again and try to improve as we go by doing those iterations in our design. Yeah.
Okay. Now, you mentioned something that I wanted to bring up to the panel, and that is the materials aspect. How can construction decarbonize when we continue to use cement, glass, steel, all the traditional materials that have been used for many years for obvious reasons? How do you start looking at the decarbonization journey when those materials are still there? Is it about trying to change some of those materials as well? And that's an open question.
I can start and then pass on, or if anyone would like to start first. Okay, so for materials, sorry, I don't want to take everybody's, just a quick one. For materials, I think the easy win there is to look at cement replacement to reduce our carbon metrics. This is really an easy win. We've got cement replacement available, GGBS and PFA in the market. However, these come at also a high, they are carbon intensive. They are coming from carbon intensive processes. And ideally, moving forward towards net zero, we are hoping that we will have another binder other than cement. Not forgetting that concrete is able to reabsorb carbon due to a process called carbonization, which happens throughout the lifetime of the structure. So this is also a positive side of the concrete that we need to look at.
I can offer an additional comment on that. I think, as you say, the challenge is that we're using materials, and everything that we do, it doesn't really matter how much we try and refine it or find replacements. We're ultimately consuming materials and consuming resources. And so one of the big areas, I think, where there's a lot of opportunity, and I think it's quite an interesting one for the market here, is about reuse of material that's already been extracted. There is a lot of existing buildings, particularly within the UAE, that are underutilized, and the tendency, I think, is just to sort of knock stuff down and start again. And I think we can be a little more intelligent about that, a little better understanding what's the asset that's available there, what's the opportunity, and actually try and reusing those materials in some areas.
You talked about there not being much data in this region at the moment, so what sort of data are you trying to build to actually get to that point where you can start really mining and analysing?
Yeah, the main data that we look to build our benchmarks are environmental product declarations, which come from the materials themselves. Now, these are widely available in the European and North American markets. It's more providers of their materials are incentivized to produce and register their materials under environmental product declarations, which give you those carbon rates that you then use in your embodied carbon measurements. It's less common in the Middle East. There are some. We have a limited database at AECOM that we draw on, but it's not big enough really to set any particular asset benchmarks at the moment. It's very interesting to hear what you said about the data that you have that you may be shortly releasing on structural elements, which is, as I said in my presentation, a very key part of the design and construction process, and a bit that AECOM particularly are focusing on in terms of carbon measurement. But yeah, the data really, from my perspective, is driven by those EPDs and lack of EPDs at the moment.
The circular economy of construction, I think, is a really interesting area. It's in a way a little hard to understand, but how much do you see that growing? I mean, you talked about some of the reuse, and it's funny because you took me by surprise in a way, Jose, when you were talking about how you reuse, because I'd been thinking it would be almost like a decommission, looking at materials you could reuse, and that was how you were approaching circular economy. But actually it wasn't that at all. It was about existing infrastructure and just thinking again how that could be used in a different way to meet a need that you had. So what sort of other opportunities can you see for the industry around that circular construction aspect?
Well, that application that I've explained is quite applicable in the region, because in desalination, the technology that has been used here is MSF, is through evaporation. So that technology is less efficient, so it's being changed by reverse osmosis. And there is many IWPP projects which has similar design, and this replacement of MSF to reverse osmosis desalination plants brings an opportunity to have the same case that I've explained, just to build a narrow, big scale diesel plant without the need of having an intake or an outfall structure to be built. In fact, we have another example in Saudi Arabia, in Al Khobar, which we have used the existing intake to build the desalination plant. So get rid of the stuff is the most important thing to avoid building is, I think, the key in this point. Yeah.
Regarding the trees, this might be very interesting for you. I was just attending another seminar last Sunday in World Environment Day. Similar topic came up, and one of the organizers, they related this to completely different industry, and they came up with a solution, say, okay, if you want to have 1,000 visas and we have 1,000 trees, so what they're going to do is in the coming days, they're going to plant 1,000 trees against 1,000 visas will be allotted to them as an organization. And the Gulf tree, you know, the Gulf tree is very important as a cultural symbol for the United Arab Emirates. So based on that, this is a new concept that's just come. It was very fresh, and they're going to start doing that. And now I represent Kanab, and I'm thinking, wow, I think we've been here, we didn't see it coming. And somebody who had an experience from outside, and we can learn this from and take back home and develop. And I see exactly what you're looking for. But my question to you is, you're doing business here, but these trees are not planted here. So your business and the people are here, your profits are here. So how do you compensate this against that?
We are working with a company called 3 Nations. That plants for us, we don't do it by ourselves. And they choose the different projects that they have in Africa, in India mainly, also in Europe, but we choose mainly the project in Africa and in India. And they plant this on areas where it's grown naturally, where you don't have to have waters, for example. So that's why we choose for now those projects there. But we discussed earlier today with some people in Saudi to try to find other projects and other ways to do that, avoiding at the maximum the needs of artificial water, if I can say like this. But we are working on it, and we are open to discuss that, and yeah, especially in the regions where the GAF tree You don't need to put irrigations normally for that, so we could work on it, yes.
We were really impressed with the CO2 offset and the planting trees in the world. My question is that the tools were invented to perform. Is there same performance for the tool when they are corded? And when they're cordless, when you shift it from a corded tool to cordless, or from petrol operating tool to cordless, are we getting the same performance, or we are compensating the performance on the expense of preserving the nature? Thank you.
No, the trees is on the top of the rest, but our first things is to be more performant than the corded or petrol tools. And the technology that you have on electrical motors or batteries now are way beyond the petrol engine. It's like your car. If you see a Tesla car, accelerations against a normal car, there is no comparison. It's the same for the tools. You don't have this time the reaction time. You have the instant full torque and full power. So, and you have much more control. It's safer also because with the electronics you can calibrate it for the end users. You can make sure that if you have some movement, the tool stopped and avoid to break the wrist of the end user, for example. So, no, it's more performant now and way more safer.